I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation of a TechNet webcast. Now it's my pleasure to introduce today's first presenter, Kartik Damhen. Kartik, you now have the floor.
Thank you, Kevin. So my name is Kartik, and I will be covering data warehouse scaling and performance for SQL Server 2008 R2. So first I'll just start off with what we're going to be covering. And we're going to start off with covering SQL Server 2008 R2 data warehouse optimization, so specific things that exist within SQL Server 2008 R2 that make data warehousing scale better than our previous versions. We'll also be talking about some of the new data warehouse scalability features in SQL Server 2008, so things that have changed since our previous versions of the product. So our agenda for today is we're going to start off with exploring parallelism. We're going to talk about some of the enhancements we've made in SQL Server 2008 along the lines of parallelism. We're going to talk about data compression, and data compression is a new feature in SQL Server 2008, and we'll go into how it works and the different kinds of data compression. After that, we'll cover looking at star join query optimizations and enhancements we've made around that, and then we'll talk about reviewing grouping sets, and those are new features that change the way you may write queries of union all and group by statements. In terms of partition table parallelism, parallelism was introduced in SQL Server 2005. Now, one of the issues with parallelism in SQL Server 2005 is that it accessed partitions with a single thread, and we've changed that in SQL Server 2008. So parallelism in 2005 worked great when you had to just go after a small subset of a table or a partition. But the second you had to scan multiple partitions to get data, it didn't really perform well, and that was because we only had a single thread per partition. So you would have to read the first partition and then move on to the second partition with one thread. So we weren't really taking advantage of the CPU on the machine. So let's look at this example we have. We have our orders table, and it's partitioned on a weekly basis based on order date. Monday morning, somebody comes in and runs a report. It runs great response, and that's because we're only hitting one partition of that data. Tuesday morning, we need to run that weekly report, and now we're reading data from two different partitions, the Monday partition and the Tuesday partition. So it's running slower, users are unhappy, and that's because of the single thread nature of the optimizer reading from each partition. So in SQL Server 2008, we've alleviated this issue by allowing multiple threads across partitions. So when we go to read data from a single partition, we'll multi-thread. If we go to read data from more than one partition, in parallel, we're going to be able to read from each of those partitions. So that makes it a lot faster. It consumes more CPU, though, in the process, but that's okay because it's only a temporary condition, and with that, we're actually able to finish that query faster. We'll notice the CPU spike, but it's temporary, but we're actually getting more use out of our resources. Another enhancement we've made is what we call few outer rows parallelism. Now, this is a very specific feature. It's a specific optimization for nested loop joins. What it does is it optimizes threaded joins that were single-threaded in SQL 2005. So just like with the other example I showed you, we had single-thread parallelism. So in SQL 2008, this facilitates parallelism for nested loop joins when the outer side has only a few rows. So the optimizer will pick up that I'm running a nested loop join. A great example of this in the data warehousing scenario would be you would have a dimension such as customer, and you'd be accessing orders as a fact table. You may have few customers you're looking at, and so what this is going to do is, with those fewer rows, we're going to parallel read. So in SQL 2005, where we only had one thread for these joins, now we're able to parallelize these threads and have more of them. Again, this increases the parallelism and also some of the CPU, but again, it's just temporary. And this really scales well in SQL Server 2008. So the key to remember is the difference here for the few outer rows parallelism is in SQL 2005, we're only using one thread for this optimization, and in SQL Server 2008, we're using multiple threads for this. So I want to jump in and ask a couple of review questions as we go through. So which of the following optimizes threaded joins that were previously single-threaded? So yeah, as you're answering the questions, just feel free to go ahead and respond to them. And as I get enough responses, we'll move on, and we'll also review these questions as we go through. So the correct answer to that is few outer rows parallelism, as we just discussed. Next question we have is, which version's threading model results in greater CPU utilization? And the key thing to remember is using more CPU on your server is not a problem. You want to use all the CPUs on the server, and the more of the CPU you can use, the more utilization you're getting out of your hardware, as well as your query performance increases by using increased amount of CPU. And the correct answer to that is SQL Server 2008, and that's because of the changes we've made in the threading to the parallelism. Next section we're going to cover is going to be data compression. Data compression is new to SQL Server 2008. We have two types of compression, row compression and page compression. Row compression works by simply removing the null and zero values in a column. And through that, we're actually able to get a lot of compression on our data, which saves us money on our storage, and because we're using less CPU, we're using less storage. We also increase the amount of I/O capability we have, because now the data is smaller. We actually store the data on the page compressed. So now when we pull the page out off the disk and into memory, we're doing less I/O to get that page from the disk into memory. We take a hit on the CPU because the CPU is what does the uncompresses the data as it's displayed or as it's sent. So with row compression really fits well in a couple of scenarios. And the scenarios it fits well in is a table that has a high amount of DML activity. So if you have a high OLTP system, it's a real good choice for that. It compresses highly transactional tables really well. And what it's doing, as you can see from this example here, is we start out with our table, and we've got a couple of repeating values. So if you look at unit cost, we see 32, and that's able to take that and turn it into a column prefix. And then that column prefix is stored once in the column prefixes, and there's a pointer to it. So we see where we have 32 for unit cost. We have CA, and then CA is stored only one time. Now we go a step further with page compression. Page compression takes benefit of the column and dictionary compression. So when we go through this, two different types of redundancy are eliminated in page compression by using column prefix compression and dictionary compression. Column prefix compression is a technique that looks for common byte patterns at the beginning of the column. So this is only at the beginning of the column across all rows on that page. So this means that the column prefix compression is byte agnostic and searches for patterns of common byte regardless of the data type. So let's take an example of we have the last name John and we have the last name Johnson. Both of them start with John. So John will be stored once in the column prefix, and then there'll be a pointer to the additional pieces of data that are stored there. So if more than one instance of the byte pattern is found in the same column, SQL Server will store the pattern once on the page and replace the pattern with a pointer to the reference in each occurrence. Any additional data that is located after the pattern is appended to the pointer to represent the complete value. So keep in mind that the byte patterns are searched for only at the beginning of the column, so anything occurring in the middle where it's replicated, that won't take effect with this. So similar to column prefixes, page dictionaries store byte patterns. The difference between the column prefixes and the page dictionary is that it's actually now looking across multiple columns. So in this example, we have the column prefixes that we have in row N page, and now we also have the dictionary compression. The dictionary compression looks across the columns. So it will take into account product ID as well as group ID. And if it sees the same pattern, it stores that once in the dictionary, and then again there's a pointer to that. And so with compression, we generally are, in a lot of instances I've seen, we're actually able to save up to about 50%. So we're able to cut our data storage size in half in a lot of instances. So I'm actually going to go ahead now and show you a demo on page compression. So this is a demo environment I'm working with, and the demonstration I'm going to show you is we're going to review some space used in the sample database, and then we're going to go ahead and estimate the compression savings. I'll show you how to compress the table through a wizard, and then we're going to go a step further and we're going to look at partitioning a table and compressing a partition table. So as you can see, I bring up my demo environment. I've got SQL Server 2008 R2 loaded, and I've got a sample database I'm going to show you and work with, and this is called Real Warehouse Sample. And this is actually a database that we've been using based on customer references as a project to show how this really works. And so REAL actually is an acronym, and it stands for Reference Implementation End-to-End, at scale, and lots of users. So this is actually the project REAL that we're using to show some of this stuff. So I'm just going to simply go in here and open up a query window, and I'm actually going to connect to the database. I'm just going to do an SP space use to get the amount of space used by this database. And so what we can see is we have about, the database is 685 megabytes. There's about 61 unallocated bytes. Megabytes of data. So next thing I'm going to do is I'm actually going to open up another file and get the amount of space used for each table. And I'm going to open up this query to get table sizes. So what this query is actually doing is it's creating a temporary table, and then I'm going to use the for each loop and insert the table sizes from each of the tables into this temporary table and display them. So in here, I'm going to go ahead and just kind of show you what we've got here. So we've got these two we've got a fact table and a dimension table that show up at the top. What I can tell you is that the dimension customer table has a little over 200,000 rows and takes up about 44 megabytes of storage. And then I look at the other table that has the same number of rows, the fact division strategy table. It has roughly about the same amount of rows, but there's a lot less storage. It occupies a lot less space on the database. So in this, I'm able to actually see, the dimension customer table might be a good table to compress based on the size of it. So now I'm going to go ahead and estimate my compression savings. How much space can I get by looking at these tables to compress? And so we have a stored procedure in SQL Server 2008 called SP Estimate Data Compression Savings. And so I'm going to actually go and look at this table. I'm going to look at that dimension customer table that we were working with. And so what this is going to do is when I execute this query, it'll take a couple of seconds here to return because it's actually going through and looking at how much space I can save on this table. It's going to come back to me with some results that are going to show me how large the table is, and if I were to use page level compression, how much compression could I get out of it. And there it is. And so the key things to notice here are the table name, the index ID. The index ID of 0 means that it's a heap and that there is no clustered index on it. If I had an index of 1, that would be the clustered index, and anything higher than 3 would be non-clustered indexes. It also shows me the partition number. And so I know with this table, I do not have partitioning set on this table. I've only got one partition for it. So now the key here is, another thing we're going to look at is we're going to look at the size with the current compression settings. So right now there's no compression, and we know that it's taking up 44 meg. And if we were to use page level compression, we see how much we're going to save. We're going to get down to about 27 megabytes of data on that table. And so that's the key thing to look at. We're also going to go ahead and look at the row compression to see how much we can get with row if we were to compress at the row level. And execute this again. So it takes a second to run, but it's actually telling us how much we could save with that. So it's a good query to run against things that you're looking to compress. And so we could see here, in this instance, we're really not going to get much out of the row compression. It's going from about 44 megabytes to about 38 megabytes. So, we're probably going to go for page level compression because it's going to get us a lot more space. And in the meantime, I'm also going to look at that other table that we spoke of earlier, the other table that had the same amount of rows, and that is fact div strategy. And we'll start off first looking at the row compression, how much we can get out of that. And so here's another example of what I was talking about. There are two indexes on here. I've got a clustered index and a non-clustered index, but I've still got one partition. And now I can look and see for index, because I can compress either indexes or tables. I can look and see how much savings I can get with compression. So with using row, I can get about, on the clustered index, I could save about half the amount of space. So from 10 megabytes to 5. Not a huge amount, but as this table grows, it could become important. But the key here to remember is that I can look at indexes and tables as well in this example. So I'm actually going to go ahead now and show you how to compress the table because that's something I'm interested in doing. So I'm actually going to come in to this database and I'm going to expand my tables. And I'm going to go and look at compressing one of these tables. And I'm going to compress it, the customer table like we were talking about. So in order to do this, it's real simple. I go right-click, and I go to Storage. In Storage, there's another tab called Manage Compression. So now this actually pulls up a wizard, and I'm actually going to walk through this wizard and see how much space I can save. So when I come in here, I have compression type, and that's a drop-down. And I'm actually going to look to do this at the page level. The next step I can do is I can calculate, and it's running that same command that I ran before. And so it knows the number of rows, and it's going to come back and tell me how much I'll be able to save with that. So the current space is 43 meg, we were at 44, and it's saying get down to 26, or 27 meg. So I just click next on the wizard, and I have a few options here I can do this. I can run it immediately, I can schedule it, I can script it to a file, or I could just go ahead and create the script and run it myself. And so what it does is it pulls up this script in the background, and it'll allow me to compress it. And so this is the command to do that. It's alter table, rebuild partition with that. And let me just make sure I'm in the right database. I've got the use statement up there, and I'm going to go ahead and execute this. And so that should take a little bit of time to do. We actually finished in 7 seconds. And so now I'm going to open up a new query, and I'm going to go ahead and just exec sp space used against this object. And I should see, and now I can see the amount of rows. I've got the number of rows we had before, and now we've actually seen how that data was compressed. And so now we can see we're down to around 27 meg of data. The next thing I'm actually going to show you, I don't want to save anything. I'm going to show you how to partition a table, And so that's the next thing we'll do. I'll just close a couple of these windows. So I'm going to go and open a file. And in order to do this, I'm going to have to add a file group. I'm going to add a file group in order to partition my next table. So simply adding a file group, I'm going to alter that database. I'm just going to add another file group to this database so I can create the partitions in those. Because with partitioning, we're going to want to use different file groups and files in order to spread out our table across our disk. So I'll go ahead and add this file group. And I'm having an issue with let me just put this on my C. Let me just try putting this on my C drive. See if that'll do it. So I'm actually having a little bit of problems creating that file group. Let me just really quickly look and see where the rest of this is stored. Find out where my database files actually are. So I've got one. Let me just see if this is my secondary file group. It's already created. It's been created ahead of time. And actually is. So this script was where I run the script before earlier during my warm-up. So I was able to create the file group successfully. And so then the next thing I'm going to do is I'm actually going to walk through creating this new file group, this partition. And we're going to partition that fact table that we were talking about before. Now, I'm not going to go much into the partitioning schema for this database, for this change. We're doing it pretty much by year. But in order to create a partition table, I need a partition function and then a partition schema. And I'll create that on top of that. So I'm going to go ahead and execute this. And the file group says no files attached to it, no files added. Let me just see what happened here. Let me add a file to that file group really quickly. File groups, file group, add a file. I want to add that. I'll quickly add a file to this. I don't want to do that. Groups. And so I need to actually add a file to this. So that's where my problem is coming in. And that's what that partitioning schema should have done. So I'm going to have to cut this one short only because it looks like I don't have a file in there. And so the key there is that we can actually compress files in there. So I'm going to go back into our content here. And come back to our deck. The key there is, and I apologize for not having looked at that a little bit before, but the key is that we can compress partition tables as well, and we can compress each partition differently. So we can actually, for each partition, we can go in there and we can compress it using page or row or none. And the key there is that we can have different types of compression for each one. So just a couple of review questions. Which is the best compression choice for transactional systems? It looks like we got a few answers in there. And everybody seems to be right there, and that's row compression. Row compression is the best choice for transactional systems, and that is because we are able to compress data, and it's just removing the null values as well from there. So the next thing we're going to look at, we have one more question. Page compression uses which of the following techniques to compress data? So we had row and we had page. And right. Correct answer to that is using both. It's using the column prefix and the dictionary compression. The next thing we're going to look at is looking at the star join query optimizations. So star join query optimizations were added in SQL Server 2008. And what this does is it actually, as we join our fact table with our dimensions, we usually filter on a column in the dimension table. So while this grouping is, and while we group on something in the fact table. So for queries that process a significant amount of fact table rows, SQL Server has new technology built in that's going to speed up the execution of that query from anywhere from 15 to 25%. The technology we use to do this is called Bloom filters. This allows SQL Server to eliminate non-qualifying fact table rows early in the query evaluation. The new star join optimization uses a series of hash joins, and it builds a hash table for each of these dimensional tables that participate. A byproduct of that hash table is a bitmap filter. And what we do is we filter on those bitmap filters. As we go through, we eliminate anything in the fact table early on that is not going to be part of the query result set. So this eliminates the need to spend CPU time later on copying the eliminated rows and probing the hash tables for them. The SQL Server 2008 query executor also reorders the bitmaps early. So they're actually reordered in a way that's easier for them from the dimension table to join against that fact table and eliminate rows as it goes through them. And as you can see, that's an example of some of those rows being eliminated as we go through. We're able to see how that works. The last thing we're going to cover is grouping sets. We're going to review the grouping sets, and these are new features in SQL Server 2008. So with grouping sets, we have this query. We'll take this query as an example. So this query uses a union all and a lot of group bys, and that's for us to get these interim results. So let's say we have results we want to join together to create a report. We're going to create these specific group by queries, and then we're going to union them all together. So something we've done is we've added a new group by operator. And the group by operator is called grouping sets. What that allows us to do is in a single query, group by different attributes as we go through. So the group, so you can have several of these sets in one query. So you can group by product category, and then in a separate portion you can also group by subcategory as well. And the column groupings show a grand total as well. So this is probably the most noted change in our relational engine to the group by clause. So this new operator allows you to aggregate several grouping sets in one query. Previously, the way to accomplish this was, again, using group by queries and then perform a union all. Grouping sets can also be used in conjunction with the roll-up and cube operators. So we can see in our brief code sample the old way to do it and the new way to do it. And as you can see, it's a lot less code too, so it's a lot more efficient, a lot faster to develop. So in this sample, we've gotten rid of that union all. And so this is another example of that query, that same query that we'll be showing you the results to right here. And so what this is doing is it's getting the calendar year, calendar quarter for a specific sales territory country, and it's giving us the sum of the sales amount. And we're looking at data for calendar year 2003 and 2004. And so the results of this query look like that. So we're actually able to create this, what looks like a report, and would be like a standard report that you might show to your users. So now I'm going to go ahead and show you a demonstration of using the grouping sets. And I'll show you, aggregation queries with the union all and aggregation query with the grouping sets. And so now I'm going to come in and open up Management Studio, and I'm going to open up my query. And so I'm going to start off by first showing you, just a group by query. And so I'm going to use the AdventureWorks data warehouse. I'm going to look at a similar query to the one we just ran. This is the same query we ran, except now we're looking at just North America data. And so when I go ahead and execute this query, I've got a simple query. I'm able to group by fiscal year and country. Nothing's ordered in this query, and this is the results that I get. Let's say I wanted to add data to this, and I have this other query. So now, that's fine for a simple group by query. I got my results, no problem. But let's say I want to union this, because in the second set, this is the same query that we just ran up here. That's the same query we just ran. But now I'm going to union it with this other query. And this query, I'm actually just looking for a little bit of different data, because I just want to group by fiscal year and sales territory country, and not by the product category name. And so that's additional data I want from there. Again, I'm looking at just North America data right there. But then I also want to get some of my null values in there. And in here too, I've got some nulls because I want the data to look the same way. So I've got null for category because I'm not grouping by it this time and getting that data. And I'm also going to create a union all and get some of the fiscal year data and some for order quantity and quantity. And again, here I'm just going to group by the fiscal year. And then lastly, my last query in that, I'm just going to get grand totals for all this data based on the territory in North America. So let me go ahead and run this. So just keep in mind all the code we have here to run this. And so now I've got this result set, and as I go down, you can see where the union all happened, where I've got some of these null values. So that was that third query, and this is the second query, third query in that set, 31 through 33, and then my grand totals are at the bottom in 34. So all that code, and now I'm actually able to do this using the grouping sets. This is how much my query has reduced in size just by using different grouping sets. So in the first one, I group by fiscal year. Second one, I group by fiscal year, sales, territory, country. And the third grouping set is adding the fiscal year, sales, territory, and English product name. So this is my grand total at the top. And then this is the first query that we ran down here, the last one, and then the other one. So using grouping sets, I'm actually able to run that query. I actually ran a little bit faster too, and get that same data that we produced in that second report. And you can tell by the fact we have 34 rows. The last example I'll show you is using group by with a roll-up. And the roll-up was, is a feature we can also use. And again, I get that same query result. So with roll-up is not anything new. Roll-up was there in SQL 2005. So it's just another way. But using these two features, using these two things with roll-up and the grouping sets, we're actually able to run this one query, this larger query, a lot faster, a lot more efficiently, and use less code to do so. So now back to our deck. And so here's another question. The more groupings we have, our performance improvement, how do we improve this? The more groupings we have, our performance improves what? And it looks like a lot of people have gotten this one too. And it's just going to show that consistently stay better than unions. The more groupings we have, our performance improves because we have less union nulls. Also the interim, there's no interim data sets. With union, all those queries are executed separately and then joined together. With the grouping sets, they're executed as one query. So grouping sets help to simplify what problem? And yeah, this is a pretty easy one to get, just based on looking at the amount of code we have there. Exactly, all of the above. So I'm just going to walk you through the session summary, and the key things to remember is parallelism is much improved because of the fact we're using multiple threads to read across parallelism, read across partitions. Bloom filters help improve the start query join, and that's because we're eliminating a lot of the work that the CPU will have to be doing by eliminating rows from our fact table early on. And lastly, grouping sets improve the efficiency of grouping aggregations. So the next sessions that are coming up are going to be something on Madison and Fast Track. Madison is what's called Parallel Data Warehouse, and that's a new SKU of SQL Server that we'll release this summer. Fast Track is a reference architecture around data warehousing, and so what that allows you to do is for scan-centric data warehouses, it allows you to, we have vendors who have come up with reference architectures around that, and with that we're actually able to get implementations of data warehouses into the field a lot faster and a lot easier for customers. And find more information, you can visit technet.com, technet.microsoft.com for more sessions, and also check out TechNet Edge at edge.technet.com. And then there's information on becoming a Microsoft certified professional. We have information on what the certifications are, why you would get certified, and what the different ones are. So that's at microsoft.com/certification. And then we have a little bit more on TechNet Plus. And this is an essential premium web-enabled live support resource that provides IT professionals with fast and easy access to Microsoft experts, software and technical information, and enhancing IT productivity, control, and planning. So feel free to check that out as well. Again, I apologize for that demo of the partition table. It just seems like I didn't have that file group created properly. So I apologize about that again. If you have any questions, please use the Ask button, and I'll be going through those in a brief minute. So yeah, ask those questions as we come up upon the survey. Kevin?
Yeah, while those questions are coming in, please take a moment to help fill in that survey. And again, please feel free to ask questions.
So let me look at the questions we have here in the queue. Okay, so the question is the multi-threading per partition is just for R2, or it also happens in SQL Server 2008? It also happens in SQL Server 2008. And is there any reason not to use data compression? For most instances, data compression is it's a given. It's a great feature. There are very few areas in which I would recommend against using data compression for data warehousing. And in terms of advocating using MOLAP or for data warehousing with these examples, all that's going to happen if you're creating cubes off of the data that's compressed is you're going to get a faster response time to read that data in. So there is a definite advantage to that because now your I/O is less. And yes, you can order grouping sets as well. That was one of the questions that came in. Somebody was asking for an example of a star join optimization. The best way to do that would be, let's say you had a customer table and you were looking for specific customers. When you go to join that to, you have a small amount of customers, let's say you have 10 customers, and you go to join that to a large fact table that has, a million of them, a million customers. Those few customers will be eliminated right from that fact table early on as opposed to later on. And besides performance and code, why else use grouping sets? It's really just for performance and code. Grouping sets perform a little faster, but that's because you're not doing all those union all, so there's no interim processing happening there. So that's where you would get that added enhancement to that. So that looks to be it for the questions. So if you just take a minute to fill out the survey, and Kevin will come back and let you know if there's anything else. Kevin.
And that's the conclusion of today's event. I'd like to thank the attendees for joining, and now you may disconnect from the audio portion of today's call.